Elena, you can start whenever you're ready.
Okay. Hi, do you see my screen?
We see the slide.
I'm not sure if I'm able to share.
Next slide is also visible.
Okay, so I have the wrong view. Let me share the right one. Okay. Give me a minute here. Oh, here it is. Okay. Okay, let me know which screen you see now. You see the...
Yep, you're all set.
Okay, great. Okay. Hi, everybody. Nice to, I guess, meet everybody. A little bit of background on this, the work group which I'm leading. It's a little bit different from the other work groups, although we work very closely together towards a mutual goal. The work group is also fairly new, and part of this presentation is an invitation to people who are interested to sign up and to join and to contribute where they can. Okay, the work group is called Linux Features for Safety Critical Systems. About myself, my background is in software engineering, architecture, security, and safety. I work at Mobileye, which is a part of Intel, and I am not, unlike most of the chairman of the other work groups, I am not a safety expert in any way. My expertise is in software engineering and safety critical, currently working on automotive systems for computer vision, autonomous vehicles, and obviously a lot of safety and security is involved there, and in an attempt to enable the use of Linux in such systems, and dealing with the more technical aspects of Linux, understanding the different features which exist in Linux and how they can be leveraged to design safe and secure systems. So the purpose in zooming in on this work group, the purpose is to bring in people with expertise in architecture, software engineering, software design, software development, integration, testing, and to see how we can support and promote existing and new proposals for features which can be useful in specific use cases as a basis for safety argumentation. And I'm very careful when I say that. We don't make any safety claims about any of these features. We provide input to those who have the knowledge and the experience to use that knowledge to use that understanding of the Linux features in order to design safety critical systems. Okay, so that's his background, and give me a second. Okay. Okay. A long-term goal for this work group, and I hope we should build up people who can contribute because it's a win-win proposal for them to work in the open source mindset. People should be introducing safety mechanisms as Linux kernel patches. I'd be a little hesitant, maybe if I would rewrite, I might change this slide. I wouldn't call them safety mechanisms, but features which have a potential to support safety mechanisms. And because again, we don't qualify them as safety mechanisms, but that they're different features which can be used to support different safety goals. Okay, I firmly believe in what it says on the bottom, that knowledge of the kernel is critical because we have to understand where the real issues exist and where we actually don't have any real problem with using Linux, because there is a tendency without that knowledge to over-engineer, and because people envision daemons which don't exist, but on the other hand, at the same time, they can miss the truly critical aspects which must be dealt with. Okay, and only this type of solid understanding can help provide that insight, which is why we are trying to pull in people who have that understanding, who have that knowledge, who know what's being done, especially learning from the domain of security, where a lot of work is done. People are developing security modules and different security features, which are used to make Linux-based systems more secure. And in the same way, we would like to promote such features for safety as well. Okay, some of the topics which we're dealing with revolve around, one of the later slides will go a little more details: memory management, fault handling, existing kernel configurations which are used to support security and can be relevant to safety. These are areas which we have worked on, but to date, in the first few months of the existence of this work group, we've only been investigating and promoting understanding to safety experts about existing kernel features. We are not up to the point yet. We are introducing new features. Okay, this builds on the mission statement of ELISA, and we take it in the sense of open source, actually developing software, deploying software components, which will be the elements, the processes, the tools, which can actually be incorporated into a Linux-based safety critical system, and supporting safety argumentation, which is amenable, meaning that in a specific use case can be used to support safety certification. Okay, and this is from the technical charter, which goes into more details, and that can be broadened into many areas, how that mission statement is actually meant to be carried out. And obviously, it requires many different aspects, many different areas, which is a joint effort of those who were yesterday at the presentations, heard about the other work groups and what they are doing. And together we work together to a mutual goal to, okay, I guess, no, what you see here, okay? So that's what this work group is about. Okay, so again, it's supporting the ELISA mission statement, and we have some representative, but we want to bring in more representatives who can help to demonstrate the use of such features, Linux kernel features in real systems. And again, we don't make those claims on safety qualification. And some of the examples, again, things which I have brought from my work, other people who are in the work group have demonstrated from their own work in deploying safety critical systems, different use of kernel features in novel ways to promote memory protection of all types, fault handling, which is something which is very, very basic, that the system should be aware of any failure and should have a deterministic reaction, which can be well tested and proven, and integrating those features in the kernel drivers, and working together with hardware vendors who promote hardware for safety critical systems with built-in features to support safety. So integrating the hardware features together with the drivers, which can be extended to handle faults or to use existing features, and integrating that within the application stack of the system. Okay, test infrastructure, dealing with multi-core, multi-process systems is a tremendous challenge because of the need for very fine-tuned scheduling, synchronization, timing, real-time systems, issues which are well known, but Linux provides very powerful tools, and we are working, this is one major area of interest, of working on expanding test infrastructure, both of in the kernel itself, and using those tools in ways which prove that a Linux-based system satisfies certain conditions, which can be documented as part of safety argumentation. Okay, watchdogs, we've gone a long way, and again, there's the automotive work group has done a lot of work on the base, the hardware, which supports a watchdog, and how that's integrated in a Linux system. We want to go beyond that to understand how we can integrate both software features of the Linux kernel and the applications on top of the kernel together with the hardware to devise a much more expanded model of watchdog for system health monitoring. And one, I added this because this is something that just came up, and it's on our list to be discussed in the work group, using existing security tools such as the Linux audit system, the audit daemon, as a base. Oops, there was a mistake, for safety runtime monitoring. That's becoming something which is more accepted in the domain of security. And again, the question really to be dealt with here is, how do we use such tools to support safety argumentation as well? Okay, so again, long-term, we want to develop features. I even made up a name. We can call them Linux safety modules, which are similar or to what are well-known Linux security modules. And those should be open source building blocks, which can be used to define applications to be used in safety critical systems. And here is an open invitation to those who want to produce some such systems, who wish to contribute, who want to join in this effort, who have what to gain from a community which focuses on this, who want to have this framework of ELISA to collaborate with safety experts so that the efforts are aligned with the expectations for safety, to support safety claims. That's what this is all about, okay? And so we want to be able to provide those tools and software components to support functional safety. Okay, and so that's basically what I have to say here. Any questions or anything to add to? Let me check the chat. I see maybe there's. Okay, I'll start with the first question. Okay, the first is just a comment about that. Igor, hi, Igor is not a newcomer. So hi, Igor. So what did he say? Not a question, but oops. But a comment, integration with Elixir would be great. So yeah, Igor, you're invited to add that to our list of topics for one of the future sessions, and it's important. Okay. George, if you can a little bit, I think I understand what you're saying, but maybe you, if you want to introduce yourself and tell me, what your background is, why you're here, what you would like to gain, and to a little bit clarify what you wrote. Georg Gitting. Hello. Those are the questions from the previous session. Oh, I didn't realize they repeat themselves. Okay. Oops. So where did they start? Okay, now I see the time.
What is the idea?
I have to look at the time on the side. I didn't realize it's a run-on chat. Okay. System health monitoring. Okay. Okay. The idea is to take work which was done by the automotive work group on a basic hardware watchdog and how it can be integrated to support, let's call it, telltales which are needed in the vehicle. Okay, I don't want to repeat everything that was said there, and to take that idea and to say, okay, that's a very basic functionality. But watchdogs can be used in a much more complex way, and the Linux kernel supports both hardware and software, and a combination of hardware and software watchdogs, which can be used in a much more extended way, not only to provide some kind of monitoring on a very, very specific hardware use case, but to extend that to the entire system. And that's where the work group will want to understand how we take existing kernel features and apply them to develop a more expanded view, a more system-wide view of health monitoring, rather than just building on what they have done there to build a much broader and system-wide view of system monitoring. Okay? So does that answer your question? Any other questions? Okay, so people are invited to join, people who think they can contribute and have what to learn. We invite people with background, safety experts who would like to learn more about the various kernel features to join, to sign up for the group and to join. Okay. If no more questions, then I think we're done for now.
Thank you, Elena.
Okay.